And I'm Jorge Arteiro. I'm a open source consultant at Microsoft. I'll do a lot of DevOps and on the cloud native space, including Docker, Kubernetes, API. I come from Azure API management. I used to be Microsoft MVP, and I used to do a lot of talks on API management and development itself. Have been speaking at Container Camp, Microsoft Ignite, API Days, Global Azure Bootcamp, few times, integration bootcamps, NDC, and some Microsoft events now. And it's my pleasure to be here and talking with you guys. And I'm that Linux guy. I have 20 years in technology already. And early 2000, beginning of my career, I did a lot of Linux development, but became this Windows guy. And now we have this technology that's Kubernetes, that's on AKS, on Azure Kubernetes Service, that we can do both. We can do Windows and we can do Linux. I want to leave here my personal community blog, website, and YouTube channel. And there's a Twitter handle there. That's probably where we can find more content that I'm producing. Fernando Vrolnik is here on the meetup as well. He's helping a lot. Nuno, Docker Captain, a lot of speakers, and it's open to anyone that want to generate content for Azure. Just ping me on support.azureta. I'm happy to record anything that you want to talk about technology, about Azure, about cloud. And if you want to know about more AKS, there are a couple of videos that we published there, how to install, and a lot about Windows Subsystem for Linux on Windows. And please subscribe to the channel and follow us. And going straight to the point, I'm not sure if many people know what Windows Container is, because that's a Kubernetes meetup. But many people start using Linux containers a long time ago, but never really use Windows Container. Then I'm going to step a little bit back before going on AKS and show what's a Windows container. Okay, there are different flavors of Windows containers, and Windows Containers one was created was a long time ago, was 2015. If you guys search my name there, you're going to see that I did a talk about API management with Windows containers in 2015, November 2015. Okay, that was the beginning, was in preview, and was a long process, and 2-3 years ago became available, but never became really available on Azure Container Service on AKS, on Kubernetes. Okay, it was available as Docker, but not as Kubernetes inside the Kubernetes. It was available if you could create your cluster, but never as a fully managed cluster. And now we have a fully managed Kubernetes cluster using those kind of containers. And in Windows containers, you can have Hyper-V containers or like a process container. If you go here on Windows Server container, that's pretty much the same as a Linux container. We have a shared kernel, and you just create your container. You have the host container where the Docker engine is running, and you have your containers running as a process, but sharing the same kernel. Microsoft, I think, was the first one in 2015 to bring that idea of have a layer of virtualization. That's what we call virtual machine here, and that's what we call Hyper-V containers. After that came a lot of things like Kata containers and others, but I think Hyper-V container was the first one. And now we have Hyper-V containers and Windows containers that's like a process, okay? That's the difference with Linux containers. The native Linux containers, that's how it works. It's pretty much compared with this one here, Windows Server containers. We have the Linux kernel, and all sharing the same Linux kernel, unless that you use something like Kata containers or that kind of virtualization that became available now. But then you have a Docker, normally have a Docker engine, like a Docker daemon, okay? That's Docker a few years ago separate a library to create containers called containerd, okay? And they also open source what they call runc. That's the runtime to create the containers. And then Docker now talk containerd talk with the runtime that creates the container. And you can have multiple different flavors of that. The runc in Linux is the main one, but that's how it works. And then you have your namespace with your container. Kubernetes a little bit different. We have one thing called pods. That could be a group of containers, but that's how you compare both. Microsoft also create one thing called Linux containers on Windows. That's not many people are following. Never became like fully production ready, but works, okay? I can even show here. You can run, let's say, Nginx or Alpine inside a Windows server. That's very, very, very interesting. And that's how that works. You have the hypervisor, and you can have the Windows kernel. Then that's how the Windows container works. You have a host container service here. That's containerd talks and creates the container. But to make Linux containers to run on Windows, they create one thing, guest container service that pretty much calls runc and creates the container the same way that Linux containers is created. But they use what they call a utility VM. That utility VM is pretty much very stateless, and lightweight VM. And that work here from Linux container, that's why I'm talking about this. That was the beginning of the work that today become Windows Subsystem for Linux version 2, where you can have full Linux inside Windows. And if you never use Windows Subsystem for Linux, WSL2 now, I have a few videos on Azure channel, and go there and install. And Docker now on Windows, when you install Docker for Windows, you are using Windows Subsystem for Linux. There's no other option. We move away from VMs. And this technology here was the beginning of WSL2. Let's try to go ahead. And then we can go back for AKS. Okay. Before I go here, there's any questions on that thing? Is something that's very interesting, and maybe you never heard about these 3 slides here that I put. I did this talk like 3 years ago, but now still not many people know about this. And if you have any question.
I got a couple of questions, but I'll wait to see if the other audience members have any questions on what you have presented so far. You'll either can put the message in the chat and I can read it out, or you can directly ask the question. Maybe I'll go first. So which of these ones Microsoft is retaining, Jorge, at the moment? Or is it all of them they're retaining, or are they only retaining the? I know WSL2 they're keeping, and a lot of efforts gone into it. The previous diagram you showed, are they going to keep both of the?
This one here, let's go back here. You mean this one?
Yeah, this one, yeah. Is Microsoft going to keep both the virtual, the Hyper-V container as well as the Windows Server container, or?
Yeah, it's a good question. They're going to maintain both.
Mm-hmm.
Today, when you talk about AKS, you're going to see that we're running Windows Server containers.
Mm-hmm.
There is a work on Kubernetes itself. I think it will be from the next version. Next couple of versions, we're going to start having Hyper-V containers coming.
Right.
And I think not just even Hyper-V, it will be all the kind of virtualization containers happening on Kubernetes. And if you look the issues on GitHub for Kubernetes, on Windows. You're going to find a lot of work being done on that. And another thing that we move away from Docker engine itself, and that's all going to be based on containerd. Okay, and then you'll be pretty much like, this guy here, container service host, will be talking with, the Kubernetes. Pretty much will be HCS shim. That's for Kubernetes. And I'm going to share here. It's all open source, by the way. You can find all the code. And I have it on my browser here open. I can show. Maybe I should show now because I think that's the right moment. And you can see this Microsoft HCM shim. That's the work being done to Kubernetes. Okay, and if you go on command, you can see containerd here.
Right.
And you can see HAN HCS. HAN HCS is pretty much that's the one I have open here. That's the runtime for Windows. Okay, then that's pretty much what creates a container on Windows. And if you install these things here, you can create containers independent of Docker. You can create Windows containers the same way that we created, Linux containers using containerd without Docker. You now can do that as well, and that's the piece here.
Right.
And those is all open source now. You can, containerd. You have these. That's how Kubernetes talk with and creates the container. Then the kubelet talks with containerd. On Windows nodes, we still using Docker. Okay, we're not going containerd directly. AKS itself is moving away from Docker engine for Linux. Containerd is in preview at the moment. You can create an AKS cluster. You can create this AKS cluster here using containerd. For Linux nodes, Windows nodes probably coming once Kubernetes be ready. There are some work to be done, on upstream Kubernetes for that to happen. And that's all here, and that's all that happen, on these things and on Kubernetes itself. And, it's GA, is very stable, but still work to be done. And if you go on Microsoft documentation, you can understand what we call isolation. See Hyper-V isolation or process isolation. I can even probably better do that now. When you install Docker for Windows, Docker for Windows here, you can see that you can switch that for Windows containers. Okay, there is a switch between Windows containers and Linux containers. I'm just going to switch to Windows containers. Then I'm going to do a Docker image. You're going to see that I have a lot. I have the latest version of Windows. That's 2004. It was just released a few weeks ago. And you have the 2019, long service version. That version here, that's the version used by Kubernetes, because the long service version. When the next one come, I think end of the year, something we're going to be changing. But at the moment, that's the one that we use. And if you guys go here and I do a Docker PS to see, you see that I have that 2004 running here. Okay. And I think I did the command here. You see that I create that using process isolation. Means that that's new, by the way, on Windows 10. Windows 10 was only available with Hyper-V containers. Now, from 2004, okay, that's brand new. You can run Windows containers locally using process isolation. What that means, that's very lightweight. It's less memory, and it's good for development. But what's the catch here? You have to use the same version of your system, because my Windows is 2004 already. I can run that. But if I try to run something different, let me try to run that. If I try to run, let's try to run 2019. You're going to say that the container operating systems here doesn't match the hosting operating system. Okay?
Oh, I see.
Okay,
Right,
that
right.
means that what I have to do, I have to come here and I have to change this. I have to change this to Hyper-V. When I change that to Hyper-V,
You can run it.
I can run it. Okay, that's very important. And there you go. See, I have Hyper-V running here. I'm inside the container. If I do Control P and key, I go outside. The container is still running.
Yeah.
That's like AKS container. And that's the main difference. You can do Hyper-V or you can do process, but process you have to go for the version that the operating system that you're using at the moment.
Right, right.
Okay, and that's, if you go back here, that's pretty much what we discussed. We running this container or that one. And now we have both. We can run that both on Windows 10, and
Yes.
that's very good. I hope it was clear, and
No, thanks. Yeah, no, thank you. Yeah, yeah. Looks like I think we haven't got any other questions at the moment. We can carry on, and if there are other questions come up, I'll post
exactly.
them.
Then I go for it. Yeah, start with AKS just to make sure that everyone has that understand. Maybe someone that never, is brand new on the meetup and or watching this video is kind of AKS or Kubernetes itself. We have what they call the masters. Okay, the master on AKS is a full managed service. Okay, or they call Azure Managed, is managed by Azure. If you don't want SLA, service level agreement with Microsoft, you don't pay anything for that master. Okay, that master is free. We just give what we call service levels objective. We guarantee the service, but if there is an outage, we're not going to pay you anything back because of this outage. But like a month ago, we released SLA as well. You can pay amount to have a SLA for these masters as well. That's very good for enterprise or for someone that really wants have like a contracted agreement with Microsoft. How that works? The master is pretty much how Kubernetes works. You have the API server, is an API. Normally, fully managed service using REST APIs here. Inside the cluster, they all talk with the API server using gRPC because it's faster. But with the external world, they're normally using REST API. That's something that sometimes people. I said before in a video that using gRPC, but just to be clear, to be easier to talk the world, normally use REST APIs. And inside the cluster, they all talk using gRPC. That's a very fast protocol. And etcd is the database, a key value, where everything is stored. Then normally use the YAML files to send like state configuration for Kubernetes. That's how we call Kubernetes YAML files. We send this YAML file for the API server, asking them to, let's say, deploy application. They have some controllers, running here, and they have this scheduler. And once that is converted on like a command from the YAML file, that goes for the scheduler that talk with the cluster. Okay, what's a cluster? A cluster in not just in Kubernetes, but a cluster is a group of nodes. Nodes on public cloud we call VMs. Okay, let's say I want to create a cluster with 2 nodes or 2 VMs. When you create these clusters, AKS is going to create 2 VMs and it's going to install the Kubernetes components. And normally those components are the kubelets. That's where they scheduler and they talk with the kubelet to create containers. Okay, and the kubelet talk with the runtime, could be Docker, Containerd. Okay, we're moving for Linux nodes. Container will be the the standard, be the default very soon. For Windows nodes, that's still like Docker, and then we create the containers or the pods, how Kubernetes call. Okay, there are kube proxy here where all the routing happens, and that's how Kubernetes works. There's no difference here for AKS. Main difference is we are fully managing this side, the master side here. And there's one thing that we're going to see how we manage Linux and Windows nodes inside the same cluster. I think that's the first question that we have here. If I jump on this slide first, probably be easier to explain. The master, we're going to hide inside this blue box. That's to say the control plane. Let's call this control plane. Okay, that's the Kubernetes AKS master control plane here. We don't have to care. It's fully managed by Microsoft. We don't even have access to the nodes, to anything here. Okay, just to the API of Kubernetes, and we talk with this API. As like kubectl from your machine, we talk with this one here. The first thing here is we can have this cluster completely in private now. That's a new thing. You don't have to expose this to the internet. If you're in a private cluster, you can have it. If you're on a public endpoint, you can have it as well. If you have a private, then you need a jump box to have access to that. Kubernetes AKS allows to create what we call node pools. Okay, node pools are a group of VMs, and you have to choose the type, Linux or Windows. And you can have, I think, at least 10 or node pools at the moment. I think this number is still 10. But the number of the machines in total, I think it can have a big number now. I think it's 1,000 at the moment. And you have to group these in 10, maximum of 10 node pools. Why need node pools? We even have in preview now, we can have node pools in different subnets. Okay. That's one thing. Then we can have subnet isolation. That's one option. The life cycle of those pools are different. First now is like you have Linux and Windows, they are different. But you could have a couple of Windows pools, a couple of Linux pools. Why need separate pools? The first thing, those things can scale differently. Let's say you're going to install or deploy some applications in one pool that maybe have 5 nodes. Maybe another application will be running another pool with like 20 nodes. Okay, that's just an example. That's a way to isolate. And you can even have different Kubernetes version runs on each pool. Okay, as long as the node Kubernetes version for the pool is compatible with the master that you're running, that's fine. Means that you can have a master running on 17 and those pools running one version down or something. Okay, normally Kubernetes like 2 versions down, they're still compatible. And that's nice too, that you don't have to upgrade everything at the same time. That make a lot of flexibility. And one thing to keep in mind that AKS can also integrate with what we call serverless containers that we call Azure Container Instance. That's like what we call virtual kubelet. We just create inside the master of a fake kubelet, what we call virtual kubelet. And Kubernetes thinks that they have like a node, but that's not a node. That's something running on Azure that's going to run inside this serverless container instance. Okay, if you never see, that's like similar with AWS Fargate, or that's what they call serverless containers. But it's all running from Kubernetes. Okay, Kubernetes doesn't know that's running there, but they're just running on the serverless. That's how a Windows pool. Now we can change this coming soon to GA. Okay, I forgot to change here, but GA. And that fully master, now you don't have to care anymore. I did this presentation, I think 3 years ago, where this thing was to be used to manage that. Before you used to have ACS, where you have to manage things. Now you don't need to manage anymore. And that's pretty much how the Windows nodes works, and all your content will be running here still with Docker, and all the proxy and load balancers work as any other cloud. Once you deploy, you can expose public IPs on those load balancers and have like a DNS endpoint, pointing to this public IP and have your traffic coming inside the cluster. I just want to go back here on that slide about the networking. A Kubernetes cluster on Azure is fully integrated with Azure Virtual Network, what you call VNet. Okay, when you create a cluster, you connect that with, we have a plugin Azure called Azure CNI, Container Network Interface for Azure, where the cluster is deployed inside a subnet inside the virtual network. Okay, you don't have to, you can have an existing VNet, subnet. You can even share this subnet with other servers, like a normal VM outside the cluster. Don't have to be, just for the cluster. You can share. And on the storage side, you can see here that we have integration with, Azure Disks or Azure Files. Azure Files, you can mount that as a SMB on your container. And the nice thing, Azure Files, you can mount that inside multiple containers. Azure Disk normally just for one pod, and Azure File will be for multiple pods. And that's how it works. Then you have storage, you have networking, and the deployment on AKS is the same as any other Kubernetes cluster. You have your source code, you do your Docker build, you push your image to the container registry. We have Azure Container Registry, if I never use. When you build the image, you're going to have your layers. You can have all the Windows-based image from Microsoft. They all now running on that MCR. Used to be Microsoft, that we moved to a different domain. It's not inside Docker Hub anymore. It's hosted by Microsoft itself. That's more, probably safer for the users. But you can even host your image inside your private container registry. And any tool that you're going to use, kubectl, Helm, or any other CI/CD tool, you're going to deploy that on Docker or Kubernetes. Docker will be just normal Windows containers, and Kubernetes now is that with Windows containers is fully, operational, and that's pretty much what I show on that. And I recommend all these tools for development on Windows. Okay, the new Windows Terminal, Windows Subsystem for Linux, even for Windows development. Okay, we're going to see that a lot of things is running on Windows Subsystem for Linux. You can have Cloud Shell. Cloud Shell is pretty much, you can have Bash or PowerShell hosted by Microsoft. And that's very handy, when you on the go, you have your laptop, you can connect from anywhere and use Cloud Shell. You have even local storage, like private storage, that you can store your private files there. And you can use these like a shell on the cloud. Another thing is with Docker for Windows, you have you can have your single node. I'm going to get out here just to show that. Let me just a second here. If you switch for Linux containers, you don't have these on Windows containers, okay? But because Kubernetes is running on Linux. But if you switch to Linux container, you can see Kubernetes here. Docker is creating Kubernetes files, okay, Docker desktop, and then if you go in settings, you probably, if you're using Kubernetes, you're probably using that already. But if you're using a Mac, but it's all available on Windows as well. And you can see now I have 118 even running here in a local cluster. And for Docker on Windows, we have integration with Windows Subsystem for Linux. Then I have all these Linux distribution running here. And if I go on my Windows terminal, that's the new Windows terminal, you can see that now I have all those Linux distros. See, I'm running Linux here. And that's not running, let me just clear here. If you go wsl.exe-l-v, you can see that I have all these Linux distros running here, and Docker is running inside a WSL now. Docker desktop, they separate into distros, but that's what Docker is running inside Windows now. Go in PowerShell, do that command, and you can see where Docker is running. And that's very nice to understand.
What's the base operating system the Docker desktop running on, George?
Yeah, Docker desktop now is running on WSL. It's not running on, before used to use Hyper-V to create a or Linux Kit to create a VM, okay, to create a full Linux VM. But now, you know, that I talk about Linux container on Windows, that WSL is using that. Then, you know, your Linux is, there's a kernel being deployed here. It's a full Linux kernel being deployed with Windows now. Okay, then it's like a full Linux now that you have here. And that's very interesting. When you go in settings,
what I'm saying is, what's the underlying operating system that the Docker desktop runs on?
Good question. Good question. They not sure. They create a distro themselves. I think it's a very lightweight one.
Right.
You can go inside. You know, if you go WSL, if you go -d, and you can go like Docker desktop, and you go inside. You connect inside that.
I'll take a look.
Yeah, but then you can see that's a Linux, but it's a full kernel now. We have a full kernel being deployed on. Yeah.
Right.
On and that's my because I switch here to Linux. If I select one cluster, okay, I don't use I have a couple of clusters on Azure. Then I go there to show. Now, you know, just to finish this thing, I think before I go there.
Sure. Yeah, sorry.
Let's just take my. Just a second, let's close my PowerPoint. Let's close here. 1 second. And what happened is, I have here my subscription. Let remove some things here. It's not here. Is that one? I create a couple of clusters here. Okay, takes like 8 to 10 minutes if you create the cluster with virtual networking, monitoring everything. It's not going to take more than 10 minutes to create a cluster. Okay, depends how many nodes you're going to create. But if you have the VNet, the monitoring, everything created takes less time. But let's say AKS Windows, okay? I create a cluster. When you create a cluster on Windows, you can let me go like that. Kubernetes service, click add, create a cluster. There's a video on Azure that we did explaining this, but you know, you create a resource group, you create your cluster, the region, the version that you want, We have 117 in production, 118 in preview. And we always have two versions now, 16 and 15, okay? From the latest one, in this case 17 now, we just removed 14. A couple of weeks ago, a week ago, we removed 14. Still running. If you have a cluster with 14, it's still running, but you cannot create new clusters. Okay, that's how Azure works. You pick your region, you pick your cluster, and you pick your VM size, how many nodes you want. One nice thing I want to show you is like node pools. You can see that they have a Linux pool. That's a minimum that you need, like is a Linux pool. But you can create Windows pools here. You can create, Windows 1 and pick different size. You can choose a size. Say one of that one. And now I have a pool. Can you create another one? Yes, you can create multiple pools. Say virtual nodes that I was talking about, you can enable, disable. You have to use scale sets. That's Azure has availability sets and scale sets. We're using our scale sets. That's a very nice thing because that's prepare your cluster to use availability zones on the feature. Azure is coming with availability zones now. That's like you now can have like similar as AWS, two zones inside the same region. I can say Sydney region in Australia. Now we have two zones, and you can spread your nodes inside multiple zones. But we're not showing that at the moment. That's still, I think, in preview, but you need scale set for that. You can use, manage identity that wasn't available maybe a few months ago, but now you can have manage identity for your cluster. This identity is how you talk with Azure. Is how the AKS class is going to talk with Microsoft Azure to create a load balancer, to create a storage, okay, to set your network and so on. We recommend always to enable role-based access control, never disable that. If you create from command line the cluster, you can integrate with Azure Active Directory as well. You can encrypt the disks of the VMs. Okay, now I have an option for you to use your custom managed key, or just trust us to manage the keys for you. Networking, okay. For Windows nodes, we need advanced network. So if I go back here, they say for Windows node pools, we need advanced network. Okay, then you have to create a network or just select one. You can do a full private cluster if you want. We recommend for Windows node to go for Azure. You're not going to have network policy for Windows nodes just yet. Okay, I think that's coming. And we can have an ingress controller for development, not recommended for production, but if you want to enable that for development, it's quite nice. It's an Nginx running on the Linux, node pool, and pretty much manage all the DNS inside Azure because Azure has a Azure DNS. And if we enable that, we're going to do, all the plumbing with Azure DNS for your ingress. That's very handy for development. I recommend for development because a single node and it's not recommended for production. And if you go for manage identity here, you're going to be able to use Azure Container Registry integration. See, I have a container registry here. Then I can tell when you create this cluster, can you just connect with my container registry? Then when I deploy something, I don't have to pass credentials about my container registry. It will be all connected already. Okay, that's handy. Maybe some case for security you don't want to do that, and we always recommend to connect the Azure monitoring. That's what we call on Azure Container Monitoring Log Analytics. I'm going to show that. I'm not going to create this cluster, okay, just to show how you create. I have a cluster created here, and I want to go for the resource groups. And I have a cluster called AKS Windows. When you create a cluster, they create two resource groups. That's where your cluster is, the main definition of the cluster. And see here we have the cluster itself. We can see how many node pools we have. We can even scale the node pools if you want to, scale manually. We recommend to enable outscaling. You can enable outscaling on the pool. Okay, is a command line. You can now enable outscaling, or you can just scale. If you want to scale, you can scale these. You have 2 nodes. You can go for more nodes, or you just enable here outscaling. Yeah, you can enable now here from here. And the nice thing now is this outscaling here is fully managed by Microsoft, because we're going to run a pod to manage this inside your cluster, but now it's fully managed by us. And it's up to you if you want to do manually or you want to do outscaling for each node pool. Okay. Once you have node pool, you manage outscaling for each one. Upgrades. If you want to upgrade your cluster, we see we're running on the latest version here. But if I close this one and I go for my demo, that's another one that I created, you can see that upgrades are available. Because I'm running 117, I could upgrade to 118. But anyway, this upgrade here is an upgrade for the master. Okay, the upgrades for the node pools, they are done here on the node pools upgrade. In this case, we're running the latest version, but the lifecycle upgrade the cluster and upgrade the pools are different. Like I said, they support, you can upgrade the master and keep the nodes 2 versions down. Then you can see, the networking and everything. The nice thing I want to show you is the monitoring. Because I have 2 clusters here, if I go on view all clusters, you can see all the clusters that the same Azure monitoring are watching. You have AKS demo, AKS wing, and you can see they both have. This one has 2 nodes, this one has 4 nodes. And if you go inside this one, that's the latest with 4 nodes. It's funny, if you go back here, you can see that we keep all the tabs. Then you can go back and get another node. You can go back here and see the previous nodes. This one here is the AKS wing cluster, where I can see the whole cluster, the CPU, memory. It's like a Kubernetes dashboard. Okay, node count, pod count. You can see each of the nodes. See, I can see what's running on each node. See, that's my Windows node. That's my Linux node. And I can see everything that's running on each one of the nodes. See, I used to have this application running here. It's not there anymore. That's why they're showing as, exclamation mark. We're going to create this one again. We can see the Kubernetes controllers. You can see the Kubernetes containers. You can even go inside the Kubernetes containers and see, the live data. You can see the container logs. Okay, you can see the environment variables from those containers. I mean, it's a very nice. And now we have in preview deployments as well. Those are all the deployments I have on my cluster. What do you guys think? I think it's very interesting. I love what's happening here on that.
Yeah, this is pretty good. This is lots more than EKS at the moment.
Yep, and that's growing a lot. If you keep following that, that's mode cluster. Is that I can jump between different clusters, and I can use what we call log analytics to to go through these logs, search. If you go in metrics, and it's very powerful here, very powerful. Okay, log analytics, we can see things we call workbooks, and you have all these metrics for all these things, and we can search and select things here, create dashboards, all integrate with even the Azure portal itself. if you want. I just want to create, show that, working. If I go here and I was just using K, get nodes, you can see that I'm connected with my AKS Windows node. But if I go here, I can swatch my context. I want to go on this one. Let's go back here. Okay, this one I have like 4 nodes, but I have 2 Windows and 2 Linux. I want to deploy on Windows, okay? And I have a very simple, just couple of things here. Is like we can deploy something like that, like a sample, okay? It's like a Kubernetes deployment. The only thing is you put a node selector. Let's say that you want to deploy on Windows. By the way, that's going to be, in some stage, you're not going to need that selector. There are some work done on upstream to change that in the feature, that they're going to be able to identify the node, the type of the container, and find the right node. But at the moment, they have to do that. And I want to run like 4 replicas of this container, and I want to expose these as a service, okay? Just because I want to open the browser, and I want to have a public endpoint, and I want to Azure load balance with a public IP. And if I go my command line and I say kubectl apply, and the file will be, let's run that win demo. That's just the file there. If you go Kubernetes get all, because I'm using the full namespace, okay? Kubernetes using namespace. When I deploy like that without saying the namespace, we're pretty much using the default namespace. And you can see that the containers are being created. They're already running now, okay? Because I have the image already there, the Docker image that I'm using. Microsoft Cache on those, VMs that we have for the cluster, like the 2019, that's the version that is used by Kubernetes. Like you cannot use a different one. You have to use the latest, the 2019, as I was showing before. You have to use this version here. Anything that's 2019, I think you have to use this. And this demo is pretty much using that. And you can see that I already have a public IP. Okay, if I go back on my cluster, I can close all these. I can go on my AKS Windows cluster. You can see that a public IP was created here. This is a public IP was created. This public IP, that's the exactly public IP that you can see here. And that's running demo application. Let's see how long that's using IIS, that's the Microsoft. See, that's not Linux, that's a Windows containers running IIS and running like a class code in ISP.NET application, where you need a full .NET framework and you need a Windows Server core to run that. It's not a nano server, it's a full Windows Server core. Okay, and if you want to do the same and you want to deploy, this IS demo that I have here, in the meantime, leave running, creating. But what I'm doing, I'm just using, a standard IS, image from Microsoft. The delays, that's like July 2020 was just released. That the latest IS version. You can build your, own image on top of this one and deploy your application. I'm just got the vanilla one and deploy 4 replicas of these the same way, exposing to the internet. And I can see that if I go get all again, We can see that now IS, I have a different IP number. Now I have both running. I have IS demo and this sample application. This one is still creating. You can see pending. Let's wait a little bit. I have the IP already, but I don't have the IS demo is still pending. The nice thing you can do as well is you can do a -OY, and you can see why it's taking longer here. I don't have the image on this one. Okay, on this cluster here, I don't have that image that I just used here. That one. That's going to take a little bit longer. But if I go here, I switch to the other cluster. See how easy it is to switch between one cluster and another. And go for my AKS demo now. If you get nodes, if you have just one Windows node, then I'm going to run the same thing, IS demo. And then cache all. You can see the containers being created. Still waiting for the public IP for this cluster. Now I have a public IP for this one. I have a node assigned. Let's go. Let's wait a little bit. Yep, container is running. Then if I go here, I should get like a standard IIS introduction page. Maybe I has to take a few seconds, I think, to start. By the way, AKS, you can, one thing is the container running, another thing is if the container is ready. There are probes that you can define on Kubernetes for this. And you have to wait a little bit for the 4 seconds. We should be there. You go. Now I have IS running. Now I have this one running one cluster, and this one running another cluster. Even I can go back on my previous one where I have both. Say it's still pending, it's still downloading the image because I don't have it. That's how it works. I hope you got a good understand what and how this thing works. And again, you can see the public IPs being created. That's where the resource for a cluster is done. You have scale sets, you have the VMs running inside scale sets. You have security groups and your load balancer. That's pretty much the whole AKS cluster. And here we have the Kubernetes resource where you can see the virtual network and you can see all the insights. Okay, just to finalize, going back inside the nodes, inside the containers or inside the deployment that's now in preview, you can see my sample deployment and you can see even live data from that. And you can see the containers. If you get the sample application, that's the one that's running. You can get live data now from the containers. You can see the container events, container logs. Don't think we have anyone for this one. But let's say core DNS, if you go here and show events, you can have any follow pretty much all your cluster here without any Kubernetes dashboard. That's not going to be the default enable anymore on AKS because nobody's maintaining the dashboard. And just to finalize, going back to my presentation. Please go through all these client tools that I'm recommending. And Azure CLI, you can have Azure CLI running, and Helm, and you need all these things to work with containers, not Linux and Windows for both. And I put a few links here. I recommend follow these guys. Stefan from Docker, Elton that used to be from Docker, and he has a very nice Windows containers workshop that you guys can follow. There's a lot of Microsoft documentation. I recommend this one here. And thank you. I'm open for questions, and also how long we have. I don't think we have much time left.
Thank you, George. Let me just check if anyone has any questions on the latter part of the session. Shamod, do we have any questions coming up?
No, Kanchan.
No questions so far?
Yeah.
Hi, Kanchana. I'm Kasun here.
Yeah, hi, Kasun. Hi, go ahead, ask the question.
Yeah. So I have a few questions because I'm not the fan with the Azure a lot, but I'm using a lot of Kubernetes with the GKS and the Azure. So my question is, so how I saw you when you are deploying something, some pods pending because of the image is downloading. So when we use like large environments, like running on like 2,000, like 3,000 pods and 200, like 100 microservices. So when we doing like deployments, that may be a trouble. So I also facing that kind of trouble sometimes. So is there any specific mechanisms you're using in, especially in like Azure? Is there any Docker registry or special features in Azure? As example, in Harbor also have the same kind of features and stuff like that. So do you guys, in Azure, is there any kind of features, and how are we going to implement those kind of features in Kubernetes? Do you have any kind of solutions for that kind of situations?
You mean to integrate AKS with the features on Azure?
Yeah, no, I'm just asking, like, sometimes, let's say, when the service is started, you can see some pods are pending, so that maybe affect the live application. So how we make performance improvements, these kind of situations? That's my general question.
Yeah, look, the Windows containers will be working as a standard Kubernetes. The way that Kubernetes, works is you can do like a kind of a blue-green deployment. Means that when you deploy the V2, you have to make sure that you do the probes correctly. Probes being, ready probe and health checks to make sure that's when the V2 is deployed and running, is available, then you're going to stop V1 and move all the traffic to V2. That works as the same way as Linux containers.
Yeah, I got your point. I'm just asking about the general Kubernetes question, not the Windows or Linux. That's fine. That's fine. You are talking about like AB deployment kind of a thing. No, just my question is not like that. But let's say your application is auto scaling. So at that time, like if it is pod is spending a little bit more time, we expected, like, let's say if it is getting like 60 seconds or something like that, that may be effect for your application, the performance. So I'm just asking.
It's a good question.
Yeah,
it's a good question because that's the main thing that people get confused when you start using with Kubernetes. You have to make sure that you make those settings. Okay, on the deployment file, you have options to do that. Okay, you can set health check probes here, readiness probes. We haven't done here on this sample, but you can see that's a very standard thing on Kubernetes. The only thing, the minimum you have to do is like a resource limits, because if you don't set the resource limits, the container is going to keep taking all the resources from the machine. You have to set, memory and CPU, but you can also set, if the pod is healthy and if the pod is red. Okay. And sometimes you can see that it's like running, but doesn't mean that's ready. Okay.
Yeah.
And that's Kubernetes works for Linux and Windows. And you can set in your deployment, in your YAML file, those configurations. You can say, You can even wait for 60 seconds if you know that takes this time for IIS to start to boot. Like Java is very common, people do that because Java takes a while. And or you can just make sure your application itself have like an endpoint, because IIS could be running, but your API could be doing some initialization.
Yeah.
And that's thing Kubernetes can do. You can have inside your YAML definition, you can have you have containers. You can have init containers here as well. We call initialization containers.
Yeah.
That has to run before. Then that's a normal Kubernetes question, but there are different ways to solve this problem. But there are options for to do everything that you're asking for.
Yeah. Thank you very much for that. Yeah.
Okay. Each deployment creates a different replica set here. And they say when you deploy this again, you'll be a different replica set that will be being created in parallel of the existing one until the next one will be ready and the application will be running, and then the traffic will be moving from one to another.
Okay.
Yeah.
Yeah,
That's the beauty of Kubernetes, that you can do that.
Yeah, that's thank you very much for that. We are also using the readiness probes and the so the health checks, and also the newly implement startup hooks. So that's also help us to do that. Yeah, I'm just asking because we also had the same kind of issue recently. Thank you very much. Yeah,
no problem.
Yeah.
Thank you, Kasun. Any other questions? A lot of people have said on the other chat channels, George, pretty good, very informative. Yeah, they're bringing me on the chat channel saying they're very informative. Thank you so much for your time. And if you had any offline questions, I'll get them to send it to your channel. And we greatly appreciate my taking the time. It's nearly 12 o'clock now. And you and Fernando as well to joining. And I will pass it on for the others who couldn't join the session today. Once again, I think on behalf of Sri Lankan Kubernetes community, thank you. Chamod, do you want to say anything, closing remarks?
Yeah, thanks a lot. And if you doing Kubernetes and you want to share something, I'm really happy, Fernando and I to record something, something that you guys are doing with anything on Windows, any Microsoft, any Azure thing in development, I'm pretty sure that you guys have something that you want to share. And the Azure thing is about helping people to start sharing, because many people have all this knowledge, but they never really wrote a blog or published anything on YouTube. And what I'm doing is helping people, to start doing that. They can publish anywhere, but I just want to help people to, to learn how to record those videos, to write blogs, and and build like leaders for the future. That's my passion. That's what I like. That's my, happy to help anyone. And thanks a lot for your time.